Another important point from the article is that this inconsistency can accumulate. At the start, the difference may be very small. One droplet spreads slightly more, another spreads slightly less, but the printed layer is built from repeated droplet interaction. Once local differences begin, they influence how later droplets join the layer. So small surface variation can become visible print inconsistency, especially in large prints, gradients, solid colors, and high detail artwork. Surface energy variation does not act alone. Temperature and humidity can change ink viscosity, drying behavior, spreading speed, and surface interaction. This can make a small surface difference more visible. Machine deposition dynamics also matter. Droplet spacing, path structure, print speed, furring stability, and droplet timing all influence layer formation. These factors can amplify a surface interaction problem. Print inconsistency from surface energy variation is not simply random. It is not automatically proof that the ink is wrong. It is not always solved by changing one printer setting, and it is not the same as a uniform print failure. The key clue is localized difference. Different regions of the same film and the same print behaving differently. If density, edge definition, or layer formation varies while setting remains stable, film surface interaction should be part of the diagnosis. When diagnosing this issue, do not only ask, did the setting change? Ask, are all droplets seeing the same surface condition? Look at whether the defect is local or global. Notice whether large areas, fine edge, solid fills, or gradients show the variation first. Separate three ideas that are often mixed together. Ink deposition is where the droplets lands. Ink spreading is how it changes shape. And the layer formation is how droplets merges into a continuous layer. Surface energy variation mainly affects spreading and layer formation. That matters because a print can have accurate droplet placement but still look inconsistent if the surface interaction is not uniform. Surface energy variation causes print inconsistency because it changes ink behavior after deposition. The same droplet can spread differently, merge differently, and build a different layer depending on where it lands. When the condition varies across the film, the result is localized inconsistency in density, edge definition, and layer uniformity. The manufacturing lesson is simple but important. Stable settings do not guarantee stable printing if the surface boundary condition is unstable. In DTF printing, print consistency depends on the full system, film surface uniformity, ink behavior, environment, and machine deposition dynamics. To troubleshoot accurately, look at the ink film surface interaction. That is how DTF troubleshooting moves from guessing to manufacturing control.